Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating systems pertaining to the BSc students studying in their 5th semester degree program. This paper is paper number 8. So we are going to see topics on unit 1. In unit 1 we have many different topics, out of which we are going to see a topic on this session. We are going to see a thread as a topic in this session. So we are going to see about threads and the different types of threads. This session is the continuation of the previous session wherein we have seen certain topics on thread. So we are going to continue this session with threads again. So in the previous session we were speaking about what a thread is, what are the features of thread, what are the benefits of using a thread, how a thread does, and what is the difference between a process and the thread. Something like as a process I said it is a heavyweight process, as a thread I said it is a lightweight. Thread is a line of execution whereas process is a program in execution. So we as well seen certain things like what is a single thread, what is a multi-thread, difference between a single thread and a multi-thread, what are the different types of thread that are available, something like the user thread and the kernel thread, and then about the multi-threading models. When it comes to multi-threading model, we saw 3 different model. One is about the one-to-one model, that is one user thread will be mapped to one kernel thread, and then we as well saw about the many-to-one thread, that is many user threads. User thread is one that has been created by a user, so many user threads has been mapped to one kernel thread. And then we as well seen about many to many threads, that is many user threads have been mapped to many kernel threads. Kernel thread is one which is been available in the operating system. The operating system has certain threads, such threads you call it as a kernel thread. A thread that has been created by user, you call it as a user thread. So in today's lecture we will be continuing with the same. After seeing the many-to-one, one-to-one, many-to-one and many-to-many models, we will see today the two-level models. That is, we will see a comparison between what is a two-level and what is a many-to-many model. What is the difference between a two-level model with that of a many-to-many model. So apart from that, in today's contents, we will be seeing topics such as thread libraries, threading issues, thread cancellation and the types of thread cancellations, signal handling, thread pools, scheduler activations, and how threads are used in the Windows XP. I will be giving you a practical example. So now in the two-level model, so you have seen about many-to-many multi-threading model. What is a many-to-many model? In the many-to-many model, many user threads are being mapped to many different threads that is available in the kernel. Then what is a two-level model? Even in the two-level model it is similar to a many-to-many model, but what is the difference between a two-level model and a many-to-many model is that here it is, it allows a user thread to be bound to a kernel thread, whereas in the many-to-many model you have a mapping between the user thread and the kernel thread. Here in the two-level model, this user thread is bounding with the kernel thread. So what is the advantage of having a bounding with respect to a kernel thread? It has been like you can have a faster set of execution. Okay, what are the operating systems that use this kind of two-level threads are? It is IRIX operating system, HPUX operating system, True 64-bit Unix operating system, Solaris 8, and the earlier versions of the Solaris operating system uses a two-level model. Then this is how a two-level model looks like. So here you have a multi-threading, wherein here you have a kernel. So this diagram is pretty similar to a many-to-many model. The only difference over here is this thread gets bounded with the thread that is available in the kernel. So there it is only mapping, in a many-to-many it is only mapping, here it gets bounded. So that is about a two-level model. Then let us speak about the different thread libraries. In the previous session, I gave you an introduction about the different thread libraries. The different thread libraries are pthreads, and the other thread is called as a Java thread. So what is a pthread? A pthread is called as a POSIX thread. What is a POSIX thread? Which is nothing but it is an IEEE standard. So we will be seeing more details on the pthreads. So here the thread library, it provides programmer with API for creating and managing the threads. So there are two primary ways of implementing. One is the library entirely in the user space, kernel level library supported by the operating system. Now we will see about a pthread. A pthread is called as a POSIX thread, which belongs to an IEEE 1003.1c. So API is a standard. So with the API standard, it is available for thread creation and synchronization. This API specifies behavior of the thread library. Implementation is up to development of the library. So these pthreads are used in operating systems such as Unix operating system, and it is as well used in certain Solaris operating systems. So and it is also used in the Mac OS as well, the Linux operating systems. So now the next thread is said to be the Java thread. The Java thread, I suppose you would have used in your when you are executing your Java language, you would have used a thread. So these threads, these Java threads are being managed or being executed and being managed by a JVM. What is a JVM? A JVM is a Java virtual machine that is available within a Java, within the Java language. So this JVM, this Java virtual machine, manages this kind of Java threads. So how it executes is that as this is typically implemented using thread model provided by the operating system whatever you are working with. So Java threads may be created by extending the thread class, implementing the runnable interface. I suppose you would have worked with the Java programs. You might be having a basic knowledge of a Java program. When you write a Java program, you write a class name and you write this class name extends this particular name, thread name. This particular thread name extends a thread name of the thread, and that implements some action listener, some runnable interface. So say for example, if you want to write a code for a mouse click event, so what you do is you write the name of the class name, class and the Java name, and you write the extends. What is the name of the thread you give? You give the name of the thread for the extends the thread name, implements. If I want to give a click for a particular button, and when it is after clicking, if it should go to a next screen, then I write a program as extends a thread name, a name of the thread, and then implements some sort of action listener, mouse click. So if I'm going to click this mouse, then what it should do. So that mouse click or the action listener, it is called as a runnable interface. And extend, you give an extend and then you give a name, that is called as a thread name. So all these things are being managed by this JVM. JVM is a Java virtual machine, and this kind of thread, writing this kind of thread, you call it as a Java thread. So next is the issues involved in threading. What are the issues that are involved in threading? What happens when you use a thread? So there are certain issues that are being available when we use this kind of threading concept. Issue number 1, the semantics of fork and exec system calls. So what is a fork? When do you generate a fork call? A fork call is generated, fork system call is called when you want to create a child process. I suppose these things we have seen in the when we are seeing the process management lecture. So in the process management lecture, we are seeing about a fork system call. A fork system call is used, it's been called in order to create a child process. A child process is created from a parent process. So this parent process has the right to create a child process, it has the right to kill a child process, and so on. So for all these things you use a fork system call, and in order to get their ID of the child process, we use an ID called as get PID, a function name. So this gets the process ID of that particular fork. So that is one thing. The second thing is the thread cancellation of target thread, which will be asynchronous or deferred. What do you mean by asynchronous? An asynchronous thread cancellation is nothing but you cancel the thread immediately. Supposing if something happens, some untoward incident happens, the system is going to shut down immediately, then that particular thread, whatever it may be the case, will get cancelled. I suppose when you use a Windows 7 or a Windows 8 operating system, supposing we are going to type something, if you are, say for example, in Microsoft Word, and supposing if your kid comes and if he is going to switch off the computer, right? So before you could save, you will be prompted with an option called as force shutdown. So when you press a force shutdown, it will not ask whether to save or not. If it is a force shutdown button is pressed, then that particular thread will get cancelled immediately. It will be aborted immediately. Such abortion you call it as, such thread cancellation you call it as an asynchronous thread cancellation. Whereas the other type of thread cancellation is called as a deferred thread cancellation. What do you mean by deferred thread cancellation? A deferred thread cancellation is one wherein you are going to have something like that particular thread will get cancelled after a particular instance of time. It will be asking you whether you want to save it or not, yes or no or cancel. Without pressing that option, you will not be allowed to switch off the system. There are other means of switching off the system. If you are going to switch off the power plug, or if you are going to switch off your UPS, your system will get switched off, but that is a different scenario. But this will be asking you for a while whether you want to save this file or not, and then after you give your particular valid input, it will say you can switch it off or switch it on. So that is called as, that is, it gives you a certain specific period of time to cancel that particular thread. Such a period given for cancellation, thread cancellation, is called as a deferred thread. So these are the two types of thread cancellations available. Then the third one is the signal handling. In the signal handling, you have synchronous signal handling and asynchronous signal handling. And then the fourth threading issue is the thread pools. So what are the thread pools? We will be seeing it in the forthcoming slides. And then about a thread specific data. So what is a thread specific data? It creates facility needed for data private to thread. So for particular thread, if I require only particular set of data, then only that data will get mapped to this thread. So that is called as a thread specific data. Then we will be saying about the scheduler activations. So what are the different types of schedulers and how it gets activated, how it is used in the Windows XP. So those details come under these threading issues. So all these threading issues we will be seeing one by one in the forthcoming slides. Now about the thread cancellation. So what is a thread cancellation? Or by and large, the thread cancellation is nothing but terminating a thread before it has finished is called as thread cancellation. I already have said about the two different types of thread cancellation. One was asynchronous thread cancellation. The other one is said to be a deferred thread cancellation. Now, what is an asynchronous thread cancellation? Before we could see the types, first we will see what is a thread cancellation, how it happens. So here it is. The thread cancellation is nothing but it is terminating a thread before it has got finished. What does it mean? That is, you are stopping a thread from its action. So it is some process is going on and you wanted to interrupt that particular process and you wanted to get rid of that, come out of that particular process. So before it gets completed, you are trying to stop that process. So as a stopping the process is of two types. So we will see the different types of thread cancellations. So one is the asynchronous approach. Second one is the deferred approach. So this asynchronous cancellation terminates the target thread immediately, and this deferred cancellation allows the target thread to periodically check if it should be cancelled. So this is what I said before the break. So if your child comes in and if he's going to shut down, if you want to do a forced shutdown, then it will not ask you whether you want to save it or not to save it, save the MS Word document which we are working with or not. So that kind of cancellation of thread, you call it as an asynchronous cancellation. And the deferred cancellation is, it will be checking periodically whether this should be saved or not. Say for example, when you have a Gmail account, you are typing in something. After every 3 seconds or 4 seconds once, your document, your mail, whatever you have typed in, will get saved in the draft folder. So, and from the draft, supposing if there is a interruption of power, or if there is a problem with an internet connectivity, then you can very well open the draft folder and then you can very well restart from place where it got saved. Or in other words, when you are using an Microsoft Word, when you are typing it, say for example you have typed somewhere around 25 pages and you have not saved at all, and say for example you are using a Microsoft Word 2003 version, Office 2003 or above. If you are not saved and suddenly if the power goes off, if you do not have an inverter connection, or if you do not have a uninterrupted power supply UPS connection, and if your computer shuts down automatically, and after the power resumes, when you are going to switch on your computer, when you open this Microsoft Word, what happens is that in the Microsoft Word you will be getting a prompt as last opened or the recovery file. This is what has been recovered. You are not saved, and do you want to save it or do you want to close it, right? No, yes, save it, no, remove these files. You will be having two different radio button options. So when you give yes, and it will be saving at the last moment where the operating system itself has saved it. So this is like you have not saved it with any means. The operating system by itself it is saving it. Similarly, when you type in certain mails, the draft, the Gmail itself saves the contents to a draft folder. You are not asking the Gmail to save it to the draft folder. So that is an example for a deferred thread cancellation. So you get certain time frame in order to before a thread gets cancelled out. So such a thread cancellation called as a deferred thread cancellation. Next is about signal handling. So what is the signal handling? Signals are used, it is pretty common in the Unix operating system. So supposing if some event happens, before the event happens, immediately the Unix operating system will pass a signal to the OS, to the user, that a particular event is going to happen. So this signal makes the user or makes the thread to get saved from being cancelled or from being stopped abruptly. So such a concept you call it as a signal handler, so which is prevalent in the Unix operating system. Now we will see more on the signal handler. A signal handler is used to process the signals. A signal is generated by a particular event. Signal is delivered to a process. Signal is handled. So it is more common in Unix operating system to notify a process that a particular event has occurred. Then what are the options of a signal handling? So what makes a particular operating system to check whether this has been handled or this has been occurred or not? So how it has been done? So the signals are delivered to the thread. So what happens when an event has occurred, when you are going to shut down a system, if you are going to shut down a Unix operating system or a Linux operating system, you will be having an automatic signal handler. It is inbuilt within the operating system, Unix or Linux. So what it does is, that signal is passed through the thread where you are working, where the word or whatever it is was working with. So it passes through the thread and it saves the locality. So that is said to be one of the option. The other things are here: deliver the signal to every thread in the process, and it delivers the signal to certain threads in a process. These are the different conditions. So first condition is it is delivering the signal to the thread which the signal applies, to the point where the MS Word, if you are going to type not MS Word, if you are going to use an Office suite in a Linux operating system, to the point where the word ends, to that point the signal reaches and it makes the thread to get saved. That is one condition. The other condition is, so it is specifically it is catching hold of that particular point and then finishing it off. The other signal condition, signal option, a signal handling option is, for every thread it delivers a signal. That is second option. The third option is it delivers a signal to the certain threads in the process. The fourth option is it assigns a specific thread to receive all signals for the process. So these are the 4 different conditions that are available. So this is about a signal handling. Now let us see a next topic of thread pools. What do you mean by thread pools? A thread is a line of execution. What is a pool literally? A pool is a big storage area, and an area where you have n number of resources available. Maybe, say for example, what is a swimming pool in general? A swimming pool is a place where you have plenty of water available. So what is the use of it? You can swim, you can jump, you can do whatever you want. Similarly, thread pool is an area where you can store multiple threads on that, and you can use the thread whenever it is required. Such a pool we call it as a thread pool. What is the advantage of having a thread pool? The advantage is you will be having an access, you will be having a faster access, because apart from the data whatever you require, you have other data as well. So you can retrieve the data whatever you want at an earlier pace. So let us list out the advantages. The first advantage is usually it is slightly faster to service a request with an existing thread that create a new thread, because you have other threads even. Second advantage is it allows the number of threads in the application to be bound to the size of the pool. Third point is it allows each thread to have its own copy of data. So because it is in the pool, so it has to allow each thread to have its own copy of data. Fourth point is it is useful when you do not have control over the thread creation process. That is, when you are using a thread pool, say for example, you at times you are allowed to create a user thread, but you are not allowed to create a kernel thread. And supposing if you do not have proper permission, if you are a guest user, wherein I suppose you might be knowing a difference between an admin user and a guest user. A guest user does not have enough privileges that the admin user has. So you will not be allowed to create, you will not be allowed to use your pen drive, you will not be allowed to use any sort of removable devices, wherein the admin has all sort of privileges. In such a case, we go in for this thread pools. So that is a thread specific data. Then let us go on to a next threading issue, the main issue called as a scheduler activation. What do you mean by a scheduler activation? A scheduler activation is one where we have seen about the multi-threading models. One of the multi-threading model was many-to-many model, wherein many user threads get mapped with many different kernel threads. So similarly, for each thread, in order to map which each thread of a kernel in the many-to-many case, this has to be scheduled by the CPU. So how it does? That is called as a scheduler activation. How this threading or this mapping of threads between the user and the kernel takes place is called as scheduler activation. So the points are both many-to-many and two-level models require communication to maintain the appropriate number of kernel threads allocated to the application. The scheduler activations provide upcalls. What is an upcall? An upcall is a communication that you receive from the kernel through a thread library. you call it as an upcall. An upcall is a communication that you receive from the kernel library through to the thread. That is called as an upcall. Then the third point is this communication allows an application to maintain the correct number of kernel threads. So these are the three different points that are required to activate a scheduler. Now let us see how these threads are used in the Windows XP. In Windows XP implements an one-to-one mapping or a kernel level mapping. So each thread, what does each thread contain? In our previous session about process, we are seeing about what does a process contain, what does this process control block contains. In that we are seeing that it contains process ID, process name, program counter, process registers, stacks, so on and so forth. So similarly in a thread, because thread is nothing but it is a subset of a process, maybe like, because process is said to be a heavyweight, thread is said to be a lightweight. So process program and execution, thread is only line of execution. It acts as a subset. So in this case, as a thread, what can it contain? Even if the process is going to have a process ID, definitely a thread will also have a thread ID. So what else it has? So this has a thread ID, a register set, separate user and kernel stacks, private data storage area. So these are the four things a thread should contain. So all these four things are available in this Windows XP thread. Then this Windows XP thread, the storage area, or which contains all these contents like the register thread, the stacks private area, and all these private storage area, you call it as a context of the thread. So we have a primary data structures of the thread includes E thread, K thread and TEB. E thread is the executive thread block, K thread is the kernel thread block, TEB is the thread environment block. So this is how it looks in a Windows XP thread environment. This is E thread where you have a start address, pointer to parent address, process, K thread again and TEB. So with this we summarize our entire session. So what are things we have seen in this session? In this session we have seen the difference between many-to-many and two-level models. We have learnt about the thread libraries. We have seen the issues in threading. We have discussed the issues in how to cancel a thread and the different types of thread cancellation. We have as well seen about signal handling. We have seen about the thread pools. We have also learnt about how to activate a scheduler, and we have discussed about the threads that has been used in Windows XP. Now let us see what are the possible questions that can arise from this session. The questions are: question number 1, what are the different thread libraries? What are the issues in threading? What is a thread cancellation? What are the types of thread cancellation? What is a signal handling? What is the purpose of thread pools? So these are the questions that are possible from this session. So with this we conclude this session. We will see more topics on operating system in the forthcoming sessions. Thank you.